All right. Excuse me. We're in section 9.7, last section in chapter 9, where we are going to be able to solve quadratic systems. You may have heard of systems in previous math courses where we were trying to solve linear equations. And it's still the same process, but all we're doing now is we're going to solve quadratic systems. So we have two conic section equations, and the intersection of those uh, two shapes in our graph are what going to be denoted as our x and y. Those are the coordinates of the intersection. So before we start solving any problems, here are the possible solutions you can have. So you could have, so if, say if it was with a linear slash quadratic system. So one equation would be a line, which is in y equals mx plus b, and then the second one is a quadratic equation, which could be one of the four conic sections. So zero solutions means that it doesn't intersect at all. So like say I'd have a line right here, and I would have a circle here on a graph. Neither one would connect, so it means that they only have the one solution. For it to have, or zero solution, I mean, for it to have one solution, say I have a line here, and say then I have like the vertex of a parabola or something. That would be considered just one solution. Two solutions, so say if I had the line again, and say I had a parabola here, or not parabola, hyperbola, and look something like this, and those two intersections would be two solutions. Say if we had two quadratic equations, two separate quadratic equations, we could have anywhere from 0 to 4 solutions. So say if like I had a hyperbola like this, and then a circle in between it, doesn't intersect. Or say I have an ellipse here, and then say I have a circle here, and it crosses, they intersect at a tangency. So that would be considered like one solution. Two solutions would be like, have like an ellipse and then like a hyperbola, something kind of like that. Three solutions would look something maybe like have an ellipse here and then parabola, so it would be considered here, here, and here. And then the last one, so say if I had like a hyperbola and then something kind of like this. Here, 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 and here. Okay? So just like solving systems of linear equations, quadratics, you can solve them, the three ways. You can use it by a graph, you could use it by substitution, and you could use it by elimination. Not everybody has a graphing calculator to punch it in, so for the two examples, I'll still just show you how to solve it using the substitution or the elimination method. So I'll just delete this right at the moment. And so take a look at example A. I have negative 3x squared plus y squared equals 13. And I got negative 3x plus y equals 1. So the second value looks like to be a line. And the top value looks like to be an ellipse. So here I'm going to use substitution. So first off, I'm going to get this to be y equals 3x plus 1. And I'm going to substitute in that into my top equation. So I got negative 3x squared plus 3x plus 1 quantity squared equals 13. And then I'm going to FOIL this out. So I got negative 3x squared, and it's going to be plus 9x squared plus 6x plus 1 equals 13. So now what I need to do is I need to get combined like terms like here and here, and then I need to set this equal to 0. So when I do that, I'm going to get 6x squared plus 6x minus 2 equals 0. Or minus 12, I'm sorry. But I can divide everything by 6, so I'm going to go divide everything by 6. It leaves me with x squared plus x minus 2 equals 0. And if I reverse FOIL here, I get x and x minus minus. I'm going to be plus minus, I'm sorry. So this is 2 and this is 1. So this leaves me with x equaling a negative 2 and x equaling a positive 1. So now all I got to do is substitute it into, I'm going to substitute it into this equation here. And if my x is negative 2, then my y will have to be negative 5. So it's going to be y equals negative 5. So that's one coordinate, negative 2 comma negative 5. And then if x is 1, my y is 4. So it intersects at 2 points. And for B, looks like I have a parabola, a line. So again, I'm going to substitute. So I'm going to have x squared equals negative 6x, which then I can go set this equals 0, so it's x squared plus 6x equals 0. I can factor out an x here, so it's x plus 6 equals 0, so x could equal 0, and x could equal negative 6. So plug those in. If x is 0, my y is 0, and then if my x is negative 6, my y is 6. So that's where it crosses. So from here, I'm just going to continue what I was doing with the substitution method. And here I have, looks like I got like a shifted ellipse and a line. So my best bet would probably to substitute in y into this equation here. So I'm left with 4 times, is it x minus 1 quantity squared plus, and this is going to be just 2x, or negative 2x squared, because the plus 3 kind of cancel it out here, and this is going to be squared, equals 4. So I'm going to expand these squares, so I'm going to FOIL out the x minus 1, and so it's going to be 4 times x squared minus 2x plus 1 plus 4x squared equals 4. Seems like each one of these has a 4 in it, so if I divide everything by 4, I'm left with x squared minus 2x plus 1 plus x squared equals 1. I get to combine like terms. I'm going to combine like terms instead equal to 0, so I got 2x squared minus 2x. Those will be 0, so this equals 0. So I can factor out a 2x here, so I got x minus 1 equals 0. Using the zero product property, I got x equaling 0 and x equaling 1. So if I plug those into the original equation, if x is 0, my y is a negative 3. And if x is 1, my y is a negative 5. So let's got two intersections. Okay. And for b, I have, I'm going to substitute it again. So this is a circle and a line. So I'm going to take y squared and plug it into here. So it's going to be x squared plus negative x minus 4 quantity squared equals 16. I'm going to expand that, so it'll be x squared plus x squared plus 8x plus 16 equals 16. So combine like terms, set the equal sign equal, set it equal to 0. So I got 2x squared plus 8x equals 0. I can factor out a 2x here. So it's x plus 4 equals 0. Zero product property, x here could equal 0 or x could equal negative 4. Plug those back into the original equation. If my x is 0, my y is a negative 4. And if my x is a negative 4, my y equals 0. So it's 2 points that it crosses at. These last two examples allow us to use the elimination method. So this is where you take both of your equations and then add them together. So ideally, you want to take one that has the opposite values and the same coefficient. So this is where the opposite values and the same coefficient. One's a negative y squared and the other one's a positive y squared. So what I can do is now I can add those two equations together, which then gives me 2x squared minus 10x plus 12 equals 0. So from here, I can divide things by 2, so I can say that's x squared minus 5x plus 6 equals 0. I can reverse FOIL that. This is x, minus minus 2 and 3, so this is going to be an x equals 2 and an x equals 3. So from here, if I have my x equals 2, it's going to be, so it was what, 4? So 2 squared is 4. That would be what, 0? So it would be what, y would have to be 0. And if x was 3, we'd have to do what, plus or minus square root of 5. So it has what, 3 solutions. So 2 comma 0, it would be at 3 comma square root of 5 and then 3 comma negative square root of 5. Okay. Last one here, same thing. This one's the opposite, so I can add those together and cancel that out. So it becomes 2x squared minus 6x plus 4 equals 0. I can divide everything by 2, so these are x squared minus 3x plus 2 equals 0. We can reverse FOIL this. So that's x minus minus 2, and 1. So x here would equal 2, and x here would equal 1. So if x was 2, my y then would be a plus or minus the square root of 22. And if my x was 1, my y would be plus or minus the square root of 11. So this one here has 4 solutions. It's got 2 comma positive square root of 22, and then 2 comma negative square root of 22. And this one's x would be what? 1 comma positive square root of 11, and then 1 comma negative square root of 11. And that is solving quadratic systems. Hope this helps. Until next time.